Good day, sir. We are the Group 11, and the assigned topic of ours is correlation and linear regression. This is an exploration of statistical relationships. So the members of this group is Miss Ivy Ripolio and yours truly, Gretchen Itiso. So first, let us define what is correlation and linear regression. So first is the correlation. It is a statistical measure that describes the degree of relationship between two variables. It quantifies how changes in one variable correspond to changes in another. The correlation coefficient, often denoted as R, ranges from -1 to +1, where -1 indicates a perfect negative correlation and 1 indicates a perfect positive correlation, and 0 indicates no correlation. So later on in this topic or in this discussion, makahibaw mo unsa ang kalahian sa perfect negative correlation, perfect positive correlation, o unsa ang no correlation. So later on we will discuss on that. Next is, what is linear regression? So it is a statistical method used to model the relationship between two variables. It assumes a linear relationship represented by a straight line, or that straight line is called regression line, to predict the value of one variable based on the value of another. The basic equation is y equals mx plus b, where y is the dependent variable, x is the independent variable, m is the slope, and b is the y-intercept. So the significance of both the correlation and linear regression is that these are the fundamental tools in statistics, providing quantitative measures and models to analyze relationships and make informed decisions based on data. Yes, so these two, the correlation and linear regression, is very important, especially to us entrepreneurs when we conduct market research. Naman dyan na involved man dyan na sige ang data, so magamit siya nato para makakonclude taog tarong sa ato ang research kabaw ta mohimo og decisions nga dapat gyud based sa data nga atong ihatag. So these two is really helpful to us. Next slide would be its significance in statistics and data analysis. First is understanding relationships. Correlation helps identify how variables are related, providing insights into patterns and associations within the data. Number 2 is prediction. Linear regression is valuable for making predictions based on observed data. It allows us to estimate an unknown variable by leveraging the relationship with a known variable. 3 is decision making. Statistical relationships revealed by correlation and linear regression are crucial for informed decision making in various fields, including finance, healthcare, and social sciences. So, as what I've said earlier, no, magamit gud siya in terms of decision making. Kaya dito ka mag-base if sakto ba imong mga decisions, imong conclusions, imong research. So yeah. Fourth is modeling and optimization. Linear regression is a foundational tool for modeling complex systems and optimizing processes. It aids in determining the impact of one variable on another. The fifth one is the research validation. Correlation and linear regression are essential in validating research hypotheses, supporting or refuting theories, and ensuring the reliability of findings. So, no, gamit yung kayo siya because gani ito jud ka mag-base sa imong mga conclusions jud sa imong research. Di ka magpataka lang abi kay muni, dili ka magpadala sa mga theories, wala nga need jud ka mga evidences, and kani correlation and linear regression, this would be very helpful guide. Makatabang ni siya nimo on how would you decide sa imong conclusions sa imong research, sa imong findings. So correlation and linear regression are fundamental tools in statistics providing quantitative measures and models to analyze relationships and make informed decisions based on data. So, di kita magbuot mo, dapat kita musunod sa process so that reliable sa ako ang mga papers and data. So, next is we will move on to understanding correlation more. So, it is a statistical measure that describes the degree of relationship between two variables, the independent variable and the dependent variable. So, naay three types of correlation which are the positive, negative, and zero correlation. So, first one is positive. Positive correlation occurs when two variables move in the same direction. As one variable increases, the other also tends to increase and vice versa. So, sa positive correlation, di ba, na duha ka variable. This is the dependent and this is the independent variable. If ang independent variable increase, automatically ang dependent variable will increase sa dili sila mag-opposite, they will move into the same direction. Example, the more hours a student studies, the higher their exam scores are likely to be. So, syempre, taas kag oras mag-study, daghan kag makuha nga information, the higher ang possibility nga taas kag grades sa exam, dako imong score. So, yeah. Next one is the negative correlation. It exists when two variables move in opposite directions. As one variable increases, the other tends to decrease and vice versa. So, opposite siya sa positive. So, syempre, obviously, it's negative correlation. So, the independent variable and the dependent variable, they will move in opposite direction. If ang independent variable will increase, the dependent variable will automatically decrease proportionately. If ang isa naman sad, ang dependent variable na sad may increase, ang independent variable na sad may decrease. So, banos-banos na sila basta opposite direction sila. Ang isa may increase, ang isa mo decrease. Example, the more hours spent commuting to work, the less free time a person may have. So ako, example, nagpuyo ko sa south of Bolhoon, mo travel ko to Cebu City. Dako kay kog hours, 4 hours ko nga mag-travel. If i-compare mo na siya sa mga sa student ka nagstay lang sa Cebu, so syempre dagan siyang mabuhat. While me, nara ko sa bus, naglingkod ra, diba? So, lahi ra jud, naa jud siya difference. Dako kay oras makuha nimo while commuting, while ang person dire nga naa na sa Cebu is daghan na kay siya mabuhat while ikaw naglingkod ra ka sa bus. So, that's the idea of negative correlation. The third type is the zero correlation or no correlation at all. It indicates the absence of a linear relationship between two variables. Changes in one variable do not predict changes in the other. So, the meaning of this is that wala gid sila connection at all. Example, diba, two variables, independent and dependent. If naay changes, example, if may increase ba siya or may decrease, ang independent variable, dili na siya maka-affect sa second variable, which is the dependent variable. Di sila maka-affect sa usag-usa. Wala sila connection, wala sila nothing. Example, there may be a zero correlation between the amount of rainfall and the stock prices of a tech company. So, nonsense kayo ang sentence kay wala gid sila connection at all, diba? Amount of rainfall, and then the stock prices of a tech company. So, di sila mag-match, di sila magtugma, like sila field. So, yeah, di sila maka-affect sa usag-usa. Bahala pag na-ay changes ang isa ka variable, di siya maka-affect sa titas. So, that is the idea of zero correlation. So, understanding these types of correlation is crucial in interpreting relationships between variables and making predictions based on data analysis. So muna siya importante nga makabaw sa tanong unsay mga types sa correlation so that makabaw sa ta mo conclude sa atong mga data so sa atong data analysis about o unsa man ang possible nga mga mahitabo, positive ba siya, negative na ba siya, a connection or wala or zero correlation at all. The next one is the correlation coefficient. So kaganina atong gi-define ang correlation. Now let's move on to correlation coefficient. Or the correlation coefficient, or represented by R, is a statistical measure that quantifies the strength and direction of the linear relationship between two variables. It ranges from -1 to +1, where R equals +1, or the perfect positive correlation. As one variable increases, the other increases proportionally. So as what I've said earlier, if ang isa ka variable mo taas, automatically ang ikaduhang variable is increase po mo taas. Next one is R. If R equals if R equals -1 or a perfect negative correlation, as one variable increases, the other decreases proportionally. So duha ka variable, ang isa mo increase, ang isa mo decrease. Next is the R equals 0 or no linear correlation or zero correlation at all. The variables are not systematically related, or wala sila connection, di sila related sa usag-usa, di sila maka-affect sa usag-usa bahalag na ay changes ang isa. So the next one is here, illustration. So diba, akong gingon kanina positive correlation, if ang isa may increase, ang isa may increase po. So as you can see, ang line there is increasing siya ang line. Sa second one, the negative correlation, if ang isa may increase, ang isa po may decrease. Ang isa may increase, ang isa may decrease. So ang slope, ang line there is downward. While sa no correlation, steady line. Wala siya correlation, di sila connected sa usag-usa, di sila maka-affect sa usag-usa. So the line there is stable in straight line. So the next topic is the correlation coefficient. Number 1, the strength of the correlation. The closer the absolute value of R is to +1, the stronger the correlation, because of course it's positive. A value of 0 indicates no correlation. Example, an R value of 0.8 suggests a stronger correlation than an R value of 0.3. Number 2, direction of the relationship. The sign of R indicates the direction of the correlation. Positive R or greater than 0 implies a positive correlation. Both variables move in the same direction. And negative R or less than 0 implies a negative correlation. The variables move in opposite directions. Okay, so understanding the correlation coefficient helps analysts and researchers like us assess the degree and nature of relationships between variables, providing insights into the pattern and trends within the data. So now let's move on to scatter plots. So what is a scatter plot? It is a graphical representation of individual data points in a two-dimensional space. Which I mean graphical, it means illustration or picture. It displays the values of two variables for each data point, with one variable on the x-axis and the other on the y-axis. Each point on the plot represents a unique combination of values for the two variables. Scatter plots are widely used in data analysis and are particularly effective for understanding the relationships between variables in a data set. So here, kadto day akong ipakita gani ng illustration nga example sa positive, negative ug zero correlation. Mo to siya gitawag nato nga scatter plot. It is a graphical representation. So, di ba importante sad siya nato kay if you're a visual learner, dali kini mo masabtan unsa ang positive correlation, unsa ang negative correlation, unsa ang no correlation without like defining them in words. You just have to look in the illustration, in the graphical representation, and you just have to analyze the picture kung unsa maning mga movement ang naa diri, na ay nag-increase, na ay nag-decrease, na ay nag-steady lang. So the next one, okay, preview sa ta. So naay mga key features ang scatter plots. First is its data points. So makita nimo diri na mga dot diha sa illustration, muna siya gitawag na to nga data points. Each data point on the scatter plot represents a specific observation or set of measurement. 2 is its x and y-axis. So the x-axis, the horizontal, ang naghigda na line, and y-axis, which is on vertical, the vertical line, represent the two variables being compared. The third key feature of scatter plot is its patterns and trends. A scatter plots help visualize patterns, trends, and relationships between variables. So, di ba, as what I've said earlier nga, dali kay nimo ma-figure out unsa ang mga patterns nga naa sa illustration, if nag-increase ba siya or nag-decrease or wala lang, because makita man nimo dayon, ma-figure out nimo dayon because of a clear representation of the data. The fourth key feature is the correlation assessment. The distribution of points can indicate the strength and direction of correlation between the variables. The fifth one is the outliers. The outliers are data points that deviate differently, significantly from the general pattern are easily identifiable. So, ang kining mga data points, ang kining outliers or data points na naglahi sa pattern, muna sila ang naglahi sa pattern, muna sila ang mga data nga murag nalahi. So, from that, makita nimo nga sila ray galahi, then, di ba, first, there is a positive correlation. Makita nimo ang dictas nga nay nagsikit diri dapit sa tunga nga pa-upward. So, ang mga naglahi dira, like, kining na ana jud dapit sa upos nga dagko kay silang gap sa isig ka data point, muna sila gitawag og outliers or mga data points na murag nasaag na nga layo na kay sila sa pattern, layo na kay sila sa trend. So, muna tawag niya. So, next is the its characteristics man gihapon ni. So, first, the strong positive correlation. So, I think I've said it earlier, but I'll just have to say it again so that you can further understand the positive, negative, and zero correlation. So, the strong positive correlation in a scatter plot, it is the points tend to form a clear upward sloping direction or pattern. As one variable increases, the other also increases. So, no naa diri naka-indicate to form, the points tend to form a clear upward sloping pattern. Upward means nagkataas, nag-increase. So, mula sila atong sige nga timan-an, muna sila yung mga keywords nga atong matiman-an, basta positive, upward. 2 is the strong negative correlation. A strong negative correlation is depicted by a clear downward sloping pattern in a scatter plot. As one variable increases, the other also decreases. So, ang keyword ani basta strong negative correlation, downward, decrease, nagka-gamay muna siya ang mga keywords nga dapat matiman-an nato when it comes to strong negative correlation. And the third one is no correlation or zero correlation or whatever you call that, is the points, is where the points are scattered randomly without forming a clear pattern or trend. So, sa katong makita ninyo sa illustration nga akong ipakita pa ganina, ang mga points is scatter, wala gyud nag-form dito og pa-upward, wala say nag-form og pa-downward, or steady lang yun ang mga points dito, wala na sila movement. So, muna siya, imong sign, basta no correlation or zero correlation at all, is that Walay nag-form nga upward, walay nag-form nga downward nga pattern or mga data points. So here, understanding scatter plot is that it's important because visualizing data through scatter plots enhances our understanding of the relationship between variables, allowing for quick identification of correlations and trends. So no, as what I've said earlier, dali ra dyan mo mainilhan kung asay naglahi, unsay changes, unsay movement, basta makita lang nimo clear ang representation sa scatter plot. So I think that's it for my part of this report. Let me pass the virtual floor to Ms. Ivory Pollo to discuss the linear regression.
So, hello everyone. Hello sir, my name is Ivy Polio and I'm gonna tackle about linear regression. So, what is linear regression? So, it is used in predicting one variable based on another. Linear regression is particularly valuable for predicting the value of the dependent variable y based on the values of the independent variable x. And the regression line derived from the data is used to make predictions by plugging in values for x and calculating the corresponding estimated values for y. So we have the example. So that's the example as you can see the screen. So consider a scenario where x represents the number of hours studied and y represents the exam score. So a linear regression model could help predict a student's exam score y, and based on the number of hours they have studied x. So the regression line would provide an estimate of the expected exam score for a given number of study hours. And we have another explanation of linear regression. So we have another explanation. So analysis is used to predict the value of a variable based on the value of another variable. So the variable you want to predict is called the dependent variable, and the variable you are using to predict the other variables is called the independent variable. So next we have, so this is the equation of a line component. So the meaning of y is the dependent variable. So that's the dependent variable. Definition: the variable we are trying to predict or understand. And we have the example. In the context of predicting exam scores, y could represent the exam score. And next we have x, so that is the independent variable. So the variable used to make predictions or explain changes and the dependent variable. And we have example, if x represents the number of hours studied, it is the independent variable. And m, so m is the slope of the regression line. So the rate at which the dependent variable y changes concerning a 1 unit change in the independent variable x. So the example, if m equals 2, it means that for every additional hour studied x, the expected exam score y increases by 2. So this is the basic linear regression equation. So as you can see the screen, y equals mx plus b. So by equals intercept. So the point where the regression line intersects the y equals axis, it represents the predicted value of y when x is 0. So example, if b equals 50, it means that when x equals 0, no hours studied, the predicted exam score is 50. So understanding the components of the linear regression equation is crucial for interpreting applying the model to make predictions based on the relationship between the variables. And next, so regression line. So the regression line is determined by minimizing the sum of square differences between the observed y observed and predicted y predicted values. Mathematically, it involves finding the values of m slope and b y-intercept that minimize the sum of y observed and predicted for all data points. This minimization process ensures that the line best represents the overall trend in the data. So regression line is important as it provides a predictive model that captures the general trend in the data, so enabling accurate predictions of the dependent variable based on the independent variable. And also the regression line, so as you can see, that is the example, that is the outline or the illustrating. This is a scatter plot illustrating the relationship between the independent variable. So you know that the regression line, it helps to make predictions based on new values of x. So and understand the overall trend in the data. So it provides a simplified representation of the relationship between the variables. So balik ta sa so again, the regression line is a straight line that best fits the data points in a scatter plot. So it represents the relationship between two variables. And for instance, in a simple linear regression, you might have one independent variable, so that's the x. If you call the independent variable, that's the x, and the dependent variable is y. So the regression line is determined by minimizing the sum of square differences between the observed values and the values predicted by the line. So next, we have residuals. So residuals is the difference between the observed y observed and predicted y predicted values in a linear regression model. Mathematically, residual of each data point is calculated as ei equals y observed I minus y predicted I. So the sum of the squared residuals, or RSS, is a measure of how well the regression line fits the data. So note that minimizing residuals is crucial for achieving a good fit. A smaller RSS indicates a better fitting model. So that is the residual sum of squares, as you can see the screen. So, and also analyzing residuals pod helps assess how well a model fits the data. Ideally, residuals should be random and evenly distributed around 0. So if patterns or trend exist in residuals, it suggests that the model may not capture certain aspects of the data. Next, we have so this is the scatter plot, the old scatter plot. So residuals, differences between observed and predicted value, play a key role in assessing the accuracy of a linear regression model. Minimizing these residuals is essential for achieving a good fit and accurately representing the relationship between variables. And next, so we have all the examples. As you can see, we have finance, economics, entrepreneurship, marketing, healthcare, education, supply chain management. So this is the example is you can apply. And of course, we have the number one, we have finance. So let's consider finance example involving a correlation. So that is the example. Correlation can be applied to analyze the relationship between the performance of different stocks in a portfolio. Linear regression may help predict future stock prices based on historical data. So I have the whole example of this. So imagine you have a portfolio of stocks and you want to assess the correlation between two of them, stock A and stock B. So if the correlation coefficient is plus 0.8, it indicates a strong positive correlation. So this means that when the price of stock A goes up, so there is a high probability that the price of stock B will also go up. So conversely, if the correlation coefficient were 0.8, it would suggest a strong negative correlation in this case. So when stock A price increases, stock B's price is likely to decrease. And next we have economics. Economics. So the economics we have okay, let's consider also the correlation between economics. So consumer example, this is correlation could be used to study the relationship between unemployment rates and inflation. Linear regression might help forecast the impact of changes in interest rates on consumer spending. So we have another example. So in a growing economy, consumers tend to have higher income and confidence, leading to increased spending. So this positive correlation reflects how consumer spending can be an indicator of economic health. Conversely, during an economic downturn, consumer spending often decreases, showcasing a negative correlation with economic growth. And next, we have the entrepreneurship. So let's consider an entrepreneurship example involving the linear regression. So imagine you're starting a business, a small e-commerce business, and want to predict future sales based on advertising spending. So first, you have the data collection, the linear regression model, the training the model, prediction, and decision making. Data collection, data collection means that gather data on past advertising expenditures and corresponding sale figures. And we have the part of linear regression model. So use linear regression to create a model that predicts sales based on advertising spending the model might look like, and also predictions. With the trained model, you can now predict future sales based on planned advertising budget. And we have also decision making. So this is make informed decisions on how much to invest in advertising to achieve desired sales target. So this example illustrates how linear regression can empower entrepreneurs to make data-driven decisions regarding resource allocation and growth strategies. And next, we have marketing. So marketing, healthcare, education. As you can see, example of the marketing as linear regression can be utilized to analyze the effectiveness of advertising campaigns and sales correlation. It might help understand the relationship between social media engagement and brand loyalty. So through marketing, through social media, they can also advertising or promoting the product. So that's the way they will market. In healthcare, example correlation analysis can be applied to study the relationship between lifestyle factors and health outcomes. So linear regression, it may help predict patient outcomes based on treatment variables. And last, we have education. Linear regression can be used to predict students' performance based on various factors, such as study time and attendance. Correlation might assess the strength of the relationship between teacher, qualifications, mga student, like ilang mga achievements sa mga students, and their activities. So, the last, we have supply chain management. So, this example, linear regression may help predict product demand based on historical sales data. Correlation can be used to understand the relationship between production lead times and inventory levels.
So to conclude our report here, we have listed three main points of our report. First is correlation. It measures the strength and direction of a linear relationship between two variables, the independent and dependent one. It ranges from -1 to +1, with 0 indicating no correlation at all. Correlation does not imply causation. 2 is linear regression, models the relationship between a dependent variable and one or more independent variables. It assumes a linear connection and provides a predictive equation. Number 3 is its importance in statistical analysis. So A, understanding relationships, correlation, and regression help quantify and understand the associations between variables. Number 2, prediction. Linear regression enables predicting values based on established patterns in the data. And letter C, inference. It provides insights into the impact of independent variables on the dependent variable. So here are sources for our report, and I think that would be all for our topic, correlation and linear regression. Thank you so much for staying with us until the end. Good night, good day, and thank you so much.